Good afternoon everyone. So we'll continue with our homogeneous differential equations. So let's get into this problem. Solve x square plus 2y square dx minus xy dy. So whenever you solve homogeneous equations, you have to convert this into which form? X to the power of n, phi of y by x. That means the function should be of y by x. Okay. So the last two questions which I gave was having y by x. So we directly used putting y is equal to v into x and we continue. Okay. So here now if you see properly, you can segregate this and take x square common. Okay. So let's do that. Is equal to xy dy. I just brought this term to the other side. Okay. So here you have x square plus 2y square into dx is equal to xy dy. Here if I bring this term to the other side, what happens? X square plus 2y square divided by xy is equal to, I'll bring this dx to the other side, this becomes dy by dx. Here if I take x square common outside, what happens? If I take x square common outside, I'll get 1 plus 2 y square by x square divided by y by x is equal to dy by dx. Here also I am taking x square common outside, right? So I have to write x square here also. So this x square and this x square gets cancelled. So you are having 1 plus 2 y square by x square divided by y by x, which is equal to dy by dx. Now this question is in the form of, in the function y by x, right? So here I can use the formula. Put y is equal to vx, and what is dy by dx? Dy by dx is equal to v plus x into dv by dx. Now substituting, I'll take this as equation 1. Substituting y and dy by dx in equation 1, what will I get? One plus 2 into, in the place of y we are substituting vx, the whole square divided by x square divided by vx divided by x is equal to dy by dx. What is dy by dx? v plus x into dv by dx. Here this x square gets cancelled, x and x gets cancelled. So what is remaining? We can write this as, we'll get 1 plus 2v by v is equal to v plus x into dv by dx. So here now we have to, next step is to form variable separable form, right? So we have to bring all the v's together and x together. So I'll keep this as 1 plus 2v by v. I'll bring this v to the other side, minus v is equal to x into dv by dx. Now solve this. What do I get? 1 plus LCM. Okay, this v becomes v square whole divided by v is equal to x into dv by dx. Now I'll bring all these terms to the other side and this dx and x term to this side. Okay, what happens now? So if I bring this x to the other side, this becomes 1 by x into this becomes dx is equal to, this v comes to the numerator, these things comes to the denominator. Okay, 1 plus 2v minus v square into dv. Sorry for the mistake here, it is 2v square. Okay, it was vx the whole square, right? So this was v square. 2v square minus v square will become v square, right? So I'll apply that here. 1 by x dx is equal to v divided by 1 plus 2 minus 1 is 1, so 1 plus v square dv, right? So now integrating on both sides. So integrating on both sides, what do we get? We have integral of 1 by x dx is equal to integral of v by 1 plus v square dv. So now if you observe carefully here, if you differentiate this, you will get, if you have to get the numerator, you are missing with the 2 here, right? Differentiation of this is what? 0 plus 2v, right? So if I multiply this both the sides with 2, so multiplying 2 on both sides, what do I get? If I multiply 2 on both sides, I'll have 2 into integral of 1 by x dx is equal to integral of 2v divided by 1 plus v square dv. So now here, what is the integral of 1 by x? It is log x is equal to, here this is of the form integral of f dash of x by f of x is equal to log of the denominator, right? Log of 1 plus v square plus, I'm taking the integration constant as log c. So this can be written as to the power, right? So this can be written as log x square is equal to, this can be written as log m plus log n, that is log mn, right? Now if I take e to the power of on both sides, what happens? This becomes e to the power of log x square is equal to e to the power of log 1 plus v square into c. So now you know that if it is e to the power of, you can write this as equal to the things which is inside the bracket here, right? So that is x square is equal to 1 plus v square into c, which is your required differential equation. Our next question is solve x dy by dx is equal to y into log y minus log x. So here x dy by dx is equal to, if I take this x to the side, this would have become y by x, right? I'll take this x to the other side, so this becomes y by x into log m minus n, that is log m by n, y by x, right? So now this is of the form y by x function, right? That is x power n into function of y by x. So this is of function of y by x. So we can put y is equal to vx, dy by dx is equal to v plus x into dv by dx, substituting, if I take this as equation 1, substituting y and dy by dx as in equation 1, what do I get? I'll have v plus x into dv by dx is equal to, if you observe carefully here, we have y by x. That means from y is equal to vx, we can write y by x is nothing but v, right? So y by x I can substitute both. So y by x becomes v and log of y by x becomes v, right? So now this is of the form now variable separable form. We can segregate the variables. I'll bring this v to the other side. This becomes x dv by dx is equal to v into log of v minus v. I can bring this, dx should be in the numerator, right? So I have x dv is equal to v into log v minus v into dx. So now segregate easily. This term if I bring it this side and this x if I bring it this side, it is variable separable, right? So dv divided by, I can take v common outside, right? So I can write this as log v minus 1 is equal to dx by x, right? Now our next step is to integrate on both sides. So if we look at this denominator, integrating this denominator is a little difficult. So we can convert this into another variable. Say if I taking log v minus 1 is equal to t. if I take log v minus 1 is equal to t, what happens? Differentiate this, what happens? 1 by v is equal to dt by dv. What is dt? It is 1 by v, dv is nothing but dt, right? Now substitute all these things to this one. So we know dv by v is nothing but dt, and log v minus 1 is nothing but t, right? And is equal to dx by x. Now integrate on both sides, it will be easy for us to do, right? Integrating on both sides, what do I get? I'll have integral of dt by t is equal to integral of dx by x. This is nothing but integral of 1 by t dt is equal to integral of 1 by x dx, right? So now what is this? Log t is equal to log x plus log c, right? So now replacing t back again. So what is t? Log v minus 1, right? So this is log of log v minus 1 is equal to, this is log m plus n, that can be written as log x into c, right? Now take e to the power of, then we will get this as the answer, right? We will have e to the power of log v minus 1 is equal to e to the power of log x into c. So this can be written as log of v minus 1 is equal to x into c, right? So this is our required differential equation. And also we have to always replace this v by, what did we take v as? Y by x, right? So always we have to replace that v back again to y, okay? Y by x minus 1 is equal to x into c. For the last question also I did not replace it, so let us do that too. So for the last question this was the answer. Here also we have to replace back v. What was v here? V is nothing but x by c, y by x, the whole square into c. So this is a required differential equation. Our next question is solve y dx minus x dy is equal to root of x square plus y square into dx. So here we have to separate the variables first, right? And we have to make it in the form of y by x, right? So I'll bring dx terms together, that is y dx, this is also dx term, so minus root of x square plus y square dx. I'll bring this to the other side, is equal to plus x dy, right? Taking dx common outside, what do I get? Y minus root of x square plus y square into dx is equal to x into dy. I'll bring this dx to the other side and this comes this side. So what happens? Y minus x square plus y square divided by x is equal to dy by dx. Still it is not in the form of y by x, so I'll take x square common from these two terms. So what happens? Y minus root of x square, if I take common outside, 1 plus y square by x square whole divided by x is equal to dy by dx. In order to make this as y by x and also this as 1, what can I do? I have to multiply and divide by 1 by x. Before that I'll bring this x outside, okay? So what happens? Y minus root of x square becomes x, right? Root of 1 plus y square by x square whole divided by x is equal to dy by dx, right? So now I'll multiply and divide by 1 by x. So if I do that, this becomes y by x by x becomes 1, x by x becomes 1. Okay, so that is y by x minus x by x into root of 1 plus y square by x square whole divided by x is equal to dy by dx. So now this x and x gets cancelled, x and x gets cancelled, So our equation becomes y by x minus root of 1 plus y square by x square is equal to dy by dx. Now we have a function in y by x, right? So we can start with our methods. Okay, our first step is put y is equal to vx. That implies v is equal to y by x, and dy by dx is nothing but v plus x into dv by dx, right? Now taking this as equation 1, we can substituting y and dy by dx in equation 1. What do we get? We have y by x can be written as v, so v minus root of 1 minus v square is equal to v plus x into dv by dx, replacing dy by dx with this. Now segregate v and x terms. So what do we have? V minus root of 1 minus v square minus v, I'll bring this v to the other side, minus v is equal to x into dv by dx. So now I can bring this dx to the other side because I want dx and dv in the numerators, right? So what happens? I'll bring this x to the other side, so this becomes 1 by x dx is equal to 1 by, here plus v and minus v gets cancelled, right? So what do you have? I have minus root of 1 minus v square into dv. So we have segregated successfully. Now integrating on both sides, what do we get? 1 by x dx is equal to integral of minus, I'll keep it outside, 1 root of 1 minus v square dv. So now integration of 1 by x is log x is equal to integration of 1 by root of 1 minus v square is nothing but, okay, I made a mistake here, sorry for that. This was 1 plus, right? Yes, it was root of 1 plus, sorry for the mistake. So we have plus here, right? So 1 by root of 1 plus x square is nothing but sine h inverse of 1 plus, sine h inverse of what? Is it 1 plus v square? Sine h inverse of v plus the integration constant c. So I can either take it as integration constant c or log c. If I take it as log c, I can combine it with this, right? So I'll take it as log c. So this can be written as now log minus log, I'll bring this x to the other side and bring this term to the other side, so I can make it positive, right? Sine h inverse of v is equal to log c minus log x. So this can be written as sine h inverse of v is equal to log of c by x. So I have to replace v here. What was v? Y by x. So this is sine h inverse of y by x is equal to log c by x, which is a required differential equation. Okay, so now if I bring this x to the other side, this becomes y by x, and I already have y by x here. So it is easy for us to convert into y by x function, right? So this is dy by dx is equal to this x, I'm bringing this side, y by x plus x by x into cos square y by x. This x, if I bring it this side, I have to divide with both the terms here, right? Okay, so x and x gets cancelled here. This becomes dy by dx is equal to y by x plus cos square of y by x, which is our equation 1. Now put y is equal to vx, that implies v is equal to y by x, dy by dx is nothing but v plus x into dv by dx. Now substituting the values of y and dy by dx in equation 1, what do we get? Yes, we have v plus x into dv by dx in the place of dy by dx. Y by x is nothing but v plus cos square of y by x is again v. Now variable separable form. Okay, we'll bring this v to the other side. What happens? X dv by dx is equal to v plus cos square v minus v. So plus v minus v gets cancelled. Again bringing the dx to the other side and x terms to the side, what happens? Dv, this I'll bring it to the other side. So this becomes, okay, I'll write one more step. That would be better. Okay, cos square v. Now bring the x term to the side and v terms to the side. What happens? dv by cos square v is equal to dx by x, right? Now integrating on both sides, I get 1 by cos square v is dv is equal to integral of 1 by x dx. So what is 1 by cos? 1 by cos is nothing but secant, right? So it is sec square v dv is equal to integral of 1 by x dv. What is integration of secant square v? It's nothing but tan v is equal to log of x plus, if I take the integration constant as log c, I can write this as, replacing v, what do you get? V is nothing but y by x, right? Okay, so now log of x into c. Okay, so this is our required differential equation. We cannot change anything here. Okay, this is a required differential equation. Okay, our next question is 1 plus e to the power of x by y dx plus e to the power of x by y minus 1 by x by y dy is equal to 0. So here you have to observe two things. That is, the function is in x by y, not y by x. Okay, so I'll tell you what are the changes required. First we have to find dy by dx, right? Since it is y by x, it is dy by dx. If it is x by y, it should be dx by dy. Okay, I'll tell you why. Okay, 1 plus e to the power of x by y dx is equal to, I'll bring this term to the other side. This becomes e to the power of x by y 1 minus x by y into dy. Now I want dx by dy. Okay, so that this becomes dx. I'll bring this dy to the other side, and now this is minus e to the power of x by y into 1 minus x by y divided by this term 1 plus e to the power of x by y. So now instead of putting y is equal to vx, we have to take x is equal to vy. Wherever it was x, it becomes to y, and y becomes to x. Okay, so now here this implies x by y is nothing but v, and here you have to differentiate with respect to y. Okay, so dx by dy is equal to v into 1 plus y into dv by dy, right? Now if I take this as equation 1, I can substitute x value, or say x by y value, and dx by dy value in equation 1. What do I get? Yes, I have dx by dy. In the place of dx by dy, what do I have? V plus y into dv by dy is equal to minus e to the power of x by y is v, 1 minus v divided by 1 plus e to the power of v. Bring this v to the other side, what happens? Y into dv by dy is equal to minus e to the power of v into 1 minus v is divided by 1 plus e power v. It's not whole to the whole divided by, because this term is a separate term here, right? multiply this e to the power of v inside. What do we get? We get y into dv by dy minus e power v minus v into e power v minus v into this term whole divided by 1 plus e power v. That is, we took the LCM, that's all. Okay, y into dv by dy is equal to minus e power v minus v into e power v minus, I'm multiplying this v inside, minus into plus minus v into e power v. Okay, so now whole divided by 1 plus e to the power of v. Here this was plus, minus into minus, it was plus. So here this term and this term gets cancelled. Here it is minus e power v minus v divided by 1 plus e to the power of v y into dv by dy. Okay, so now segregate v terms and y term together. This dy I am bringing to the other side. So dv by, okay, we can write this comes to the numerator 1 plus e power v divided by minus e power v minus v, right, equal to 1 by y into dy. Now integrating on both sides, I have 1 plus e power v divided by minus, if I take common outside, I have e power v plus v into dv is equal to integral of 1 by y dy. If I take this minus outside, I'll have the integral 1 plus e to the power of v divided by e power v plus v into dv is equal to integral of 1 by y dy. See here, if I differentiate this, it is e power v plus v, that is e power v plus 1, right? So that is in the numerator. That means we can use the formula integral of f dash of x divided by f of x dx is equal to log of f of x. So this can be written as log of denominator e power v plus v is equal to log y plus log c constant. Okay, I'll take this minus sign to the other side. So what happens, this becomes log e power v plus v. You can do this way also, but this would be better, I feel. So if I take the minus sign this side, this becomes minus log y, right, minus. Okay, if I would have had taken this minus to the other side before integrating, then I would have got this plus here and this minus would have come here, right? So if this is the case, this was log m minus log n. So this is plus c itself. So this can be written as log of e power v plus v is equal to log m by n, positive terms, that is c by y. Here, check properly. This minus sign, I'm sending it to the side before integrating. So what happens? This would have had become minus integral of 1 by y dy. That means minus log y plus integration constant. Okay, don't get confused. So, okay, this is integral 1 plus e power v by e power v plus v dv is equal to minus integral of 1 by y dy. Okay. Okay. So now taking this to e raised to, and if I take it as e power on both sides, what happens? I can write this answer, right? So this becomes e power v plus v is equal to c by y, and replacing v by x by y plus x by y is equal to c by y. Sending this x by y to the other side, what happens? This becomes e power x by y is equal to c by y minus x by y, which can be written as the denominator is same, so this is by y, c minus x by y, right? So this can be written as e power x by y is equal to c minus x divided by y, which is our required differential equation. I want all of you to try this as homework 1. I hope yesterday's you have completed. Thank you.